Hello everyone, and welcome to today's webinar, Zero Trust Security, Supporting a CARTA Approach with Network Security. I am pleased to introduce today's speaker, and that is Christopher Lillenstolpe. He is the CTO of Solutions here at Tigera, and is also the original architect behind Tigera's project Calico. He speaks at let's just say a lot of meetups every year, educating people on networking and network security for modern applications. And he also does a lot of consulting with Tigera's enterprise clients on the same things, basically security and compliance for modern applications, Kubernetes, content as containers as service platforms, etc. So before I hand over the webinar to Christopher, I have a few housekeeping items I'd like to cover. About the presentation and the webinar platform in general. First off, today's webinar will be available on demand after the live session, and it will be accessible through the same link you're using now. We've also added some attachments and links to the attachments tab on your screen. We have a couple links to upcoming webinars that we are doing with partners, Arista Networks and AWS. The AWS webcast coming up, webinar is especially attractive. We are doing a case study with Atlassian, so that's a great view into how they've approached their network security. And also, if you want a copy of today's webinar, you can request that from us, and we will go ahead and get that to you. If you have any questions during today's webinar, please ask them as they come up. We will try to address those questions in the moment when we're on the slide. That way we can keep things relevant and flowing. If we don't get to your question, we will do our best to do it at the Q&A session at the end of the presentation. So without further ado, I'd like to hand things over to Christopher. Christopher.
All right. Thanks, Michael. So what we're going to talk about today is start a series on Gartner's CARTA model and how that relates to zero trust and what we're doing here at Tigera. So whether or not you believe in Gartner's, well, first of all, what is the CARTA model? So the CARTA model is sort of a life cycle of zero trust model that Gartner has put together, envisions the way people will be managing zero trust infrastructure beyond day zero, beyond setup. Whether you adhere or agree with the exact Gartner CARTA model, there's a number of interesting components to it that I think do make sense to talk about in general scope. So first, let's talk about zero trust. It's a buzzword. You know, everyone here is pulling their buzzword bingo cards out right now. So zero trust is a bit of a buzzword today, but really it encompasses some very solid security concepts that we've had in the industry for a very long time, and packages them up into one concept, zero trust. One is the concept of least privilege. Things should only be able to make connections that they need to make. You shouldn't leave connectivity available for things that don't need to have connectivity. So if we think about my classic, Bob's, Alice's, and Charlie's, if Bob and Alice need to talk, that's fine. If Alice and Charlie need to talk, that's fine. There's no reason to have Bob and Charlie being able to communicate. So concept of least privileges, you don't allow that. You only allow the connections that are communication paths that are required to accomplish the mission or to enable the application to work, etc. The second part about zero trust is that we need to be able to, with some degree of surety, ensure that those really are Bob's, Alice's, and Charlie's, and that we know what Bob, Alice, and Charlie are. So this comes similar to what we start thinking about multi-factor authentication, etc. Instead of using a single piece of data to identify something, try and use as many as possible. Maybe it's behaviors, maybe it's identity in different realms. But you start trying to build a picture so that you know or have a reasonable guarantee that Alice is Alice and Bob is Bob. So if we start taking the concepts behind MFA, multi-factor authentication, and least privilege, we start approaching this concept of zero trust. And the idea behind zero trust is basically there is no ultimately trusted entity in the infrastructure or in your platform. People, applications, infrastructure, etc. None of that is trustworthy. At Tigera, for a long time before all this came up, we sort of talked about not only protecting your workloads from the rest of the world, but protecting the rest of the world from your workloads. Another little thing, people who have been to my meetups have heard me say this, if you talk to the relevant organs in both private and the commercial or government sphere, there's exactly two types of organizations in this world: those that know they have an APT or advanced persistent threat in their infrastructure and those that don't. So we have to assume, and especially in today's much more dynamic world, that the bad guys are already in the perimeter. And that's where zero trust comes in. The zero trust model, we're going to make the assumption the bad guys are already in, and we're still going to try and protect the infrastructure as best as possible. So that's zero trust. That's a very long prelude to this slide. So once you start talking about zero trust, one of the things Gartner has said is that zero trust is a point-in-time thing. You configure your environment based on the way you think your environment should be working, based on your assumptions. And in a containerized world, those are usually better than they were in the legacy environment, because each of these containers does fewer things. It's easier to scope. But that's a point-in-time thing. What Gartner's saying is sort of obvious, is that you then need to evaluate how those controls are working. Are you properly identifying workloads? Is any endpoint or entity in the network able to spoof and say it's a Bob and it's really not? And how do you detect that? Are the controls you put in place too restrictive or not restrictive enough? So the whole idea behind CARTA, or one of them, is that it requires a continual reassessment of zero trust mediated flows. So basically, you do your zero trust, you then watch the infrastructure, you see the behavior, and then you make adjustments as necessary and iterate, wash, rinse, repeat. So that's sort of the CARTA approach. We've got the nice Gartner graphic here, so kudos to Gartner for drawing some nice pictures and wrapping a name around this concept. So, one of the ways that you enable a zero trust environment is, again, this concept of least privilege. What should be allowed to talk to what? Versus, so it's sort of a whitelisting model versus a blacklisting model. Most people have whitelists. I think that whitelisting is inherently difficult, and in a legacy environment where you don't know, you've inherited applications, they're big hairy applications, they open connections to everything and their brother, that's hard to do. In a more modern world where you're defining these individual microservices, this is easy. Each microservice is only going to have a couple of connections, and it's easily scoped. An example of the legacy, a previous company I worked for at one time had a very elderly platform, and no one really understood why that platform existed, so it was turned off. That's sort of the ultimate form of microsegmentation. We don't know what this is, so let's turn it off. You check, nothing happened, everything's still fine. They discovered a couple months later when they went to quarter close that platform was actually used as part of quarter close, so they had to resurrect it. So when you're doing microsegmentation or whitelisting in legacy environments, there's a bit of a challenge, and we'll talk about that. We've talked about that some before. We'll talk about that in other webinars coming up. But basically, microsegmentation is a form of whitelisting. It's usually whitelisting based on personalities or roles of things rather than individual things. So all the things that are customer front ends should be able to talk to all the things that are customer databases. Not this particular pod and this pod and this pod and this pod should be able to talk to this pod, this pod, and this pod. So when we do that, when we decide that we're going to use microsegmentation as our tool to do least privilege, which is again part of zero trust, it allows you to have enable a default deny network posture. You're not, as I said, you're not relying on things within the network necessarily, and you're establishing trust of the workloads before any network access is granted. Is this really a Bob? And if so, what is Bob allowed to talk to? Rather than allowing that pod on the net and then later trying to figure out what it's trying to talk to and make a decision if it should be allowed or not. So let's talk about what microsegmentation is. We've done this before, but we're doing this within the context of CARTA. So, we have an application graph, and this is the Bobs, Alices, and Charlies, and we haven't done anything. So the Bobs can talk to the Alices and the Charlies can talk to the Bobs and the Alices, and everyone can communicate with one another. That's great. Absolutely no security here. The end result will be predictable. So most organizations in the containerized world have, and frankly, for a long time have said a perimeter firewall is the solution to all ills. There is for those of you who like Gary Larson, there's a Far Side cartoon. If you search for Gary Far Side, hard crunchy outside, soft chewy inside, you'll see the way I view about perimeter firewalls. The idea of a perimeter firewall is the bad guys are on the outside, the good guys are on the inside. It's sort of like building a wall and a moat around your castle. The problem is once the wall and the moat is breached, there's nothing protecting you at that point. Once somebody gets in, they have full motion. It's sometimes called lateral movement, etc. And this is the way most of the breaches that have made it on the front page of the New York Times, Financial Times, etc., have started. Somebody gets into that cordon sanitaire, social engineering, bad piece of code imported, whatever, and then they have free range to lateral move around the entire estate until they find what they're looking for, in some cases over periods of months without being detected. So, this is also why very early medieval castles only had a wall and a moat, and pretty soon they started adding baileys and inner walls and outer walls and towers and dungeons, because having a single perimeter is not going to stop the attack once it gets in. So as a general rule, putting a cordon sanitaire or a perimeter firewall around things and calling it done is probably not the right answer. Not saying that perimeter firewalls aren't useful, they're just not sufficient. So microsegmentation says instead of putting the perimeter around all of the things as one big blob, why don't we put the perimeter around each endpoint? And I hate this, people say this is a new idea. Actually, back in the early days or the middle-aged days of internet networking, i.e. the 80s and 90s, which maybe I have enough gray in my beard to say I was part of. That's actually the way we sort of viewed things, is if you needed to defend your host on the net, we didn't have firewalls back then. Firewalls, we can have a long conversation about where firewalls came from, but you actually had host protection. You secured every host on the network. So we're basically coming back in this industry. Everything that's old is new again. So we're going back now to securing endpoints. So the idea is you put a perimeter around the endpoint itself. In a containerized environment, that's around each and every container. So now I put a wall around the Bobs and the Alices and Freds, and not only a wall that says around Bob that says only Alice can talk to me, but also a wall around Alice that says I can only talk to Bobs, right? So you actually put these perimeters so they're both inbound and outbound. So you now have multiple points of protection. So these filters are not just inbound filters, they're also outbound policies as well. Now, if you again have the intruder, the aggressor, the adversary get in, they have compromised exactly one workload or one very small portion of your overall infrastructure, and they're contained. Lateral movement becomes very difficult, because the first thing it has to do is figure out what lateral movement is even possible from within this pod, what connections are allowed, and if this is rendered correctly, like it is in Tigera, both our commercial and open source solutions, this is rendered correctly, then from within the pod, you can't introspect and find out what's allowed and what's not allowed, unless you're doing a brute force door knock. Scan every possible thing and see what's allowed and what's not. Hopefully, and we'll talk about this more when we get to our visibility webinar coming up soon, hopefully if something starts doing a door knock, rattling your doorknobs from within an infected pod, you'll detect it and you'll think, this is strange, that nothing should be trying to do a full port scan of my infrastructure, and you shut the thing down, problem solved. So there's really no way, if this is done right, to introspect from within the pod to decide, to figure out what paths are available to you. And the pure act of the aggressor trying to map out what is allowed so they can figure out how to do lateral movement is going to trip the alarms that you need to be able to say, hey, there's something wrong here. So that's a little bit about the, how you do this. You're blocking that aggressor from getting out, and the pure attempt of it trying to get out should set off all kinds of alarms in your infrastructure. So let's think about a basic application. So, I've got a microservices application here. It's a FooBar application. Think of it sort of like a book review. So I've got some details about the product. I've got some ratings. 1 star, 2 star, 3 star, 4 star, 5 star, and even some reviews. What did the people who gave those ratings, why did they give it that way? This is standard e-commerce kind of thing, but it's basically 3 applications all being called by another application called product page. So let's look at how this works. So product page, the front end of the application, makes calls to 2 things, reviews and details. Details about the product and the reviews, the star ratings. And, the reviews of the product, and as part of the reviews, you then go into the ratings microservice to get what the actual ratings were for a given review. So we now have 3 microservices that are all, ratings is feeding reviews, and reviews and details is feeding product page. So that's how your microservice works. That's great. What you really want to make sure now, of course, is that product page can only talk to reviews and details, and reviews can only talk to ratings. That gives you your least privilege, right? I don't need to allow details to talk to ratings, or product page to talk to ratings, or reviews to talk to details. None of those are valid paths. They shouldn't be allowed in the infrastructure. I now have another issue. So let's say this is, one side is the US and the other side is Europe on these. So I have 2 different versions of this application, one running in Europe, one running in the US. This might be because of GDPR requirements or language, but there is potentially multiple versions of this application. So let's think about policy delegation. The developer knows that product page needs to be able to talk to ratings, to reviews and details, and knows that reviews needs to be able to talk to ratings. So that's something the developer knows, and that's something they want to write policy for. Similarly, the security or compliance team has a policy that says only US apps should be able to talk to other US apps, and only EU apps should be able to talk to other EU apps, and there shouldn't, neither the twain shall meet. Don't cross the streams, for whatever reason this might be. So how do we render this? First, let's take a look at how we can do some policies around. I think this one maybe got misordered, but that's okay.
Okay.
But let's, I think that was my bad. But let's talk about, let's go back to this in just a minute. Let's go back to what this policy looks like in just a minute. Let's go down now and see if we first think about what the developer does. The developer says product pages can talk to reviews and details, and reviews can talk to ratings. They don't care where this is running. So basically, they've done this graph. Salmon can talk to green and blue, and green can talk to yellow. That's the developer's input. In parallel, the InfoSec team has a policy that says greens can only talk to greens and salmons can only talk to salmons, or US can only talk to US and EU can only talk to EU. So what we really want is a set of policies. These are two separate sets of policies, and they should be rendered separately. One policy says US nodes can only talk to US nodes, and one says EU nodes can only talk to EU nodes, and the developer has the what we call the microservice graph. So if we go down here and we start thinking about how you do this in a Kubernetes world or in a Tigera world, your policies need to be label-based, and they need to be declarative, and they need to be rendered dynamically, because this is a dynamic environment. So basically, we don't want to use IP addresses as the foundation for our filters, because IP addresses are ephemeral in Kubernetes. And we don't want to have to write policies that are the static in nature that we do with firewalls today. I don't care where it's running. From a developer standpoint, product page should only be able to talk to ratings, reviews, and details. Doesn't matter where it's running, doesn't matter about any other policy, it's just that's a rule, is what product page should be able to talk to. So let's talk a little bit about that now, and then we'll come back to the policies a little bit more. So another example of this, I have an application. Let's take a look at what that policy looks like. In this case, I have a ratings application that needs to talk to a role application. I've got another application helper that shouldn't be able to talk to the database. This is a fairly simple declarative policy now. It basically says that anything labeled ratings DB, doesn't matter if there's one of them or a million of them, will allow traffic in, that's an ingress rule, from anything labeled role ratings on port TCP 6379. With no other policy set, this is the only traffic that's going to be allowed in this cluster. So in this case, role DB will allow traffic in from ratings, but will not allow traffic in from role helper. And this is a declarative policy. We're not saying specifically what pods, anything along those lines. It's basically selector based. Anything labeled ratings should be able to talk to anything labeled role DB. So that's a declarative policy. And this is how it looks. First of all, this is a network policy. The first thing is we name it. We put it in a namespace for this application. And then we say anything labeled role DB, this policy is going to apply to. And then for anything that this policy applies to is going to allow ingress in from things labeled role ratings. So this is a basic declarative network policy. There are other things that we can do, and this is where that first policy should come from. So let's go back, Michael, to slide 15.
Yep.
So in slide 15, we've just talked about basic labeling, etc., and doing L3, L4, but now let's talk about doing this more up the stack, layer 5 through 7. Remember, we talked about zero trust, the idea of using multiple enforcement points and multiple forms of identification. So I not only have things labeled app details in this case, but I'm also saying that not only is it I'm going to apply this to app details, I'm going to allow traffic in from things with a specific kind of label in Kubernetes called a service account with the name product page. Now, the interesting thing about the service account is if you're running momentary loss of pointer. If you're running Istio, then service accounts map to TLS certificates and can be used for mutual TLS authentication. So if you have this policy, not only are we going to match this at layer 3, layer 4, we're also going to, the part of the match is going to be not only are you a Bob, but also you have a service account attached to you named product page, and that drives a MTLS authentication. So now not only is this a network filter, this is going to mandate that the appropriate MTLS exchange happens and the client can authenticate the server and vice versa. So we've now used TLS as part of our authentication mechanism. If we go back down now to slide 25, we can even group service accounts. Just like everything else in Kubernetes, you can attach a label to something, to multiple things, and have them behave as a group. So here, what we're going to do is not say a specific service account, but any service account, so long as the service account itself has a label of ratings is equal to reader. Service accounts are RBAC controlled, which means you can very tightly control who can manipulate these service accounts. So now it doesn't matter what service account, so long as that service account itself, and sort of metadata of metadata, has a label of ratings reader. Similarly, I can start putting these things together. I can start saying now if I have an app reviews, I'm going to allow traffic in provided the application label is product page and the service account has a label of reviews reader. So now I'm doing authentication based on both the L3, L4 object as well as the TLS object. This starts, I'm now making it harder and harder to subvert this because there's now multiple forms of identification I'm using, both cryptographic and based on what the orchestrator knows about a given endpoint. I can go even farther, put all this together and say, even if you have the same label, you're an app product page, and you've got a TLS certificate is tied to something labeled ratings reader, if you try and do an HTTP post, or you try and do a get to anything other than a URI prefaced by ratings, it will still be blocked. And this is starting where we're going to start talking about this CARTA ongoing introspection of your flows. I've allowed the flow because it's product page, it matched my service account match and my pod selector patch. So the flow is allowed. But the minute that flow attempts to do something that we didn't expect for it to do, in this case, do an HTTP get on something prefaced with ratings, we'll block the traffic and alert. So this is the beginning of an automated introspection of all the flows, and again, that continual evaluation. You can then go back later and say, well, why did this pod that had all the right credentials try and do something wrong? Was it a configuration error? Was it an error in code? Or was it something more malicious? Or did my boss just hire someone to do a red team on me and they're testing my security and I just passed? Woohoo! So anyway, so these policies you've been seeing, let's talk now a little bit more about these. For those of you who've managed firewall policies in the past, they're big, complex beasts, multifaceted. This thing has all of these potential connections. This other thing has all these other potential connections. That becomes hard to introspect them, hard to break them down. How many places do I need to go change to say I'm only going to allow 443 now versus port 80? All my firewall rules might have to change because these are unique to every endpoint. Instead, we can start thinking about micropolicies. Instead of saying this X, Bob's, or Bob should be able to do all these things, maybe instead the things that are of Bob's have different characteristics. Maybe they're a foo server or a foo client. So you can have a policy that says maybe Alice is also a foo server. So you can say foo servers should allow traffic from foo clients. And it doesn't matter if it's a Bob or an Alice, so long as it's a foo service, it will allow traffic from foo clients. And I'll have exactly one policy to change when foo security policy changes. When I change foo's port number or I require TLS, I change it in one place and it is reflected across the entire fleet, no matter if they're Bob's, Alice's, or George's. Similarly, I can have, and this maps this out, so I have a foo service that allows traffic from foo clients. I have a bar service that allows traffic from bar clients. In this case, anything that's labeled a foo client can only talk to a foo service. But this orange workload here is labeled both foo client and bar client and can talk to both. There's only two policies. This is not, if you thought about this in classical firewall rules, there would be three policies here. In this case, there's only two policies. Bars allows traffic from bar clients and foo allows traffic from foo clients. And that allows for now this starting to be more interesting service graph than a simple bidirectional. So that gives you a little bit about micropolicies. This allows composition of micropolicies. So we start thinking about making policies simpler. Matching the concept of micropolicies to microsegmentation, introspecting our traffic as much as possible, even at layer 7, applying concepts of least privilege. We start getting to this, zero trust model, and more importantly to this, again, you may or may not subscribe to Gartner, but this concept that they discuss in CARTA, which is now not only applying zero trust, but continually reevaluating if your zero trust posture is the correct zero trust posture. So that was a lot of stuff that I just went over in the last 30 minutes. So I think we'll take a pause here, Michael, and see if there are any questions.
So if you guys have questions, please go ahead and enter them into the questions tab in the BrightTalk interface, and we will try to get to them. And while you're typing in your questions, if you have one, just a reminder that we have 2 upcoming webinars. Next week, we are doing a joint webinar with Arista Networks, and it is entitled Kubernetes Clusters, Advanced Container Networking and Security. And
if you're tired of hearing my voice, unfortunately, you'll get that one too. So I was part of that Arista webinar, so I don't know if that will make it more interesting to you or you'll run away from it, but you'll get to hear my voice again.
Yeah. Well, we love it. So, and then also we have a joint webinar coming up on Wednesday, February 6th with AWS. And it's a case study on Atlassian and how their move to the cloud and their secure move to the cloud. So those are 2 great events coming up. It looks like we don't have any questions from the audience, and that either means that everything was perfectly clear or they're confused beyond questions. So,
or they're asleep.
Or there is a third option. So, well, if you have any questions, feel free to go ahead and shoot us questions at contact@tigera.io, and we will respond to them. Once again, I'd like to thank you guys all for attending, and hope you have a great day. Thank you.
Thank you.